The next talk is running OVS with a P4 coprocessor from Daly from Intel.
So let's then jump into the slides. Disclaimer slide. I want to start by talking about where we're looking to go. We want to build the network as this programmable platform where your SDN control application is running across your entire network, collection of switches, servers, NICs, other types of devices in there. And if we could make all of these different types of devices be programmable to some extent, and if we could have some commonality in the way that those are programmed, then this could become a really powerful place to go and build really interesting new ways to solve networking problems and maybe come up with a brand new network. And at the same time, we want to be able to look at every step of the way of that system to be able to measure how well that system is behaving, be able to detect when there's issues, and be able to fix problems that may arise inside of your programmable platform. So this is a pretty big, lofty vision. So how do we get there? And so this vision is really why we have been using P4 in different places. And with P4 adoption thus far, it's really been a mix and match where some folks are using P4 natively in their control plane applications. It makes it easier for them to define exactly what that control plane application needs to do and how it relates to the data plane underneath it. And that relationship can be defined with a runtime contract. Another usage that people have found to where P4 gives them value. And the runtime contract says from the sort of SDN software layer down to the data plane below, if you can support this data plane, I can run my application on top of it. And that's really powerful. That's something that can happen offline before you even go and build out this monstrously complex system. You can go and find out if the data plane below can satisfy the requirements of your application. The third usage, which is something that we're going to talk about a lot today, because it really it's a really important feature of P4 within OVS, is the concept of being able to sequence multiple applications inside of a data plane. So we'll go into that a little bit more. And then the fourth most well-known usage of P4 is that you can take your P4 program and you can compile it into hardware. And I think that some people think that those things are one-to-one, where you always use P4 just to do programmable hardware, but it's just one of these several usages of P4. And I think that within OVS, we can pick and choose which one of these four usages, is valuable to us if we are using OVS with P4. And so I'm going to go through a couple of these as examples as I talk about why we would want to have P4 inside of OVS. And to go back to that sequencing, application sequencing function, if I just take, and now this is a relatively complex usage, but just take the transmit path of a data plane in a system that with a configuration that's very, very interesting to many of our customers, is that I have some business logic or some tenant that is running their own networking stack, and they send a packet. And I want that packet to be Kubernetes networked. I want to do all my routing and load balancing and ACLs within Kubernetes. And then maybe I've layered below Kubernetes, I'm using OVS to give me some of those networking functions, but maybe also others to provide an infrastructure as a service abstraction. And then OVS uses the Linux infrastructure to be able to enable tunnels, do bridges, other features like that. Another common feature of OVS is to have an encrypted tunnel from vSwitch to vSwitch to protect your data as it's running across the network. And then once that data is about to be sent out of the system, we might want to use routing all the way down to the server to be able to pick that uplink, pick the next switch to send that packet to for redundancy reasons. And so I've gone through all of these different data planes to the point where I finally can send that packet out over the network. That is a lot of complexity, and we're proposing to use P4 to be able to explicitly sequence all of these different functions and to be able to allow these data planes to have their own sort of life cycle throughout the system. And this is hugely valuable because oftentimes, if you did this in the Linux kernel, it's sort of unclear as to when exactly do all of these stages apply. You have to kind of step it through and make sure you fully understand. And so with P4, it would be entirely written down and executable in terms of how all of these functions work. And then layered on top, we want to be able to see at every different stage how that pipeline is functioning. And that's where SDN can come in and give us that visibility, can give us that monitoring function, and could even help us debug this sort of train of packet processing as the packets are moving in and out of the network. And if you would take all of those different functions that we just described and tried to map out their control planes, they're all sort of independent. And today we kind of tie all these together with the Linux kernel so that FRR can have a routing table. OVS uses different functions with the tunnels. Kubernetes is very native with Linux, and StrongSwan ties in there as well. There is really no sort of SDN linkage in here, but just to show that this is sort of a little messy in terms of you have all these different control planes running around. They all have to be running sort of sequence within the Linux kernel. And then if you want to have something on top, like an SDN controller or just some sort of application that's trying to monitor all of this, it's yet again another layering of, okay, how do I get into the right places inside my data path? So then that brings us to why a coprocessor. So we started out by, and this is many years ago, to try to add P4 directly to OVS. So let's take all of the OpenFlow processing that OVS does, and let's just replace it with P4. And I think that there's definitely a lot of potential in that approach, but we didn't want to really make that type of engine swap inside of OVS to enable P4. So then the second step was, well, why don't we create a new proto to make it another option inside of OVS? And that still felt like a lot of extra, surgery to add a new proto and, create this new pathway inside of OVS. So we thought, what if we instantiated the P4 separately inside the system? And then OVS could tap into that P4 pipeline, sort of copy its state that it had out of OVS and into the P4 pipeline so it could run side by side. And we would just need to have OVS make that state synchronization function with the P4 pipeline that's running alongside it. And so that's where we landed on this coprocessor approach. It's really just saying that OVS will be another P4 speaker in the system, and we'll be able to have a set of tables and have a set of rules that it will program. Whenever it would normally program something in OpenFlow, we just copy that state over into the P4 pipeline. And so that ends up looking kind of like this, where we first instantiate the P4 pipeline. On IPDK.io, we have all the code to instantiate a fully software pipeline, but it's swappable. So if you had your P4 pipeline and it's running in hardware, running in a switch, running in an IPU, it runs exactly the same way. So you instantiate this P4 pipeline and you run the agent on top that can listen to RPC messages for clients that want to connect to this P4 pipeline. That could come from the SDN controller up top, which is totally optional, or it could come from left to right from OVS. Now, a sort of a variation on this theme is, what do you do about all of the state that is still being put inside of Linux? It's still our main mechanism for keeping all of these different control planes synchronized. So what we have done, and it's really sort of a common mechanism that other projects like Sonic have done, is that we're listening to changes in the netlink over netlink sockets, changes to the Linux networking configuration space. So if FRR comes and creates a route, sets up ECMP, or if TeamD goes and sets up LACP, then that information will be relayed from Linux over into the P4 pipeline. So we wanted to take that same mechanism where, if OVS goes and creates a tunnel, that tunnel information will go over netlink into the P4 pipeline. But then if there's a configuration in OVS, let's say a new table entry is created, new MAC address is learned, that we use P4 runtime to go over and copy that new MAC address into the P4 pipeline. And because the P4 pipeline is going to see the packets first, either they're coming from the physical network or they're coming from vhost or VF or SRIOV, because that pipeline is going to see that packet first, the copy that we've made of all the control plane state or all the data plane programming that needs to happen, that will be applied to the packet. And then if there's something that the data plane can't handle, then we can push it back into the Linux subsystem, and you can sort out those exceptions, whether it could be something as simple as, oh, I need to send this packet to the BGP stack, or an LACPDU needs to go to TeamD, or it could be a packet that my hardware or software pipeline doesn't understand and needs to go back to the software. We can sort all that out and send it to the right place within the P4 pipeline below. And something that we are starting to develop on top of this is, now that I have this P4 capability, I'm copying all the state into the pipeline, I can start to layer more applications on top. And so we have a new recipe on IPDK where we are doing offloading of the Kubernetes networking. We're offloading the routing, the ACLs, the stateful load balancer out of the Kubernetes networking and into this P4 coprocessor. And in some places, it's using a lot of the configuration of OVS to be able to do that. Really similarly, we can do the same thing with Strong Swan, where the IKE stack may negotiate a new tunnel, put inside the Security Association database a new essay, and we can copy that out of Strong Swan, and over P4 runtime send that over into the P4 pipeline. So we've taken all of these different independent control planes, and in some cases like Linux, we take a well-known path to copy the state of that control plane into the P4 pipeline. In other places, like in OVS, we're making modifications to OVS so that it can push this state over P4 runtime over into the data plane. So to do a double click on all of those different pieces, this is that same picture, just I guess with less icons. But you can see that at the bottom is our P4 DPDK pipeline. this part is swappable between a software and hardware piece. That P4 DPDK pipeline talks to vhost to get into guests. It talks to the Ethernet ports below. And then when exception packets, such as a packet that needs to go to the routing stack or a packet that needs to go to OVS, those are trapped over through on the left-hand side. And then the top half are all these P4 runtime clients that are all being arbitrated in this central piece called Infra P4D. Infra P4D, you'll see in the GitHub, is really just starting with Stratum and then adding some extra logic to be able to pull that netlink socket information from Linux. And we actually are converting that netlink socket to SCI, the switch abstraction interface from Sonic, and then we convert that into this interface we call TDI. It's a table-driven interface. So we're sort of funneling all of this different configuration down, arbitrating between it so that the P4 pipeline, which is the thing that's below TDI, sees a single stream of configuration. And so all of these different control planes get brought all together and are able to control each of their individual table space, depending on what was set up at the beginning when that pipeline was instantiated. And so this is a picture of what you can set up today inside of our IPDK repo, which contains all of these different pieces. And in the case of OVS, as was presented a little bit earlier today, this is a fork of OVS where we're slowly honing our set of patches to try to minimize the amount of changes there. And so to recap all of that, we are trying to preserve all the existing data planes, and we are trying to add in, in the cases where you do need to go and move that state from from OVS to P4, we just translate those OpenFlow rules to a set of P4 runtime function calls over RPC, and then that goes and sets that up inside of the pipeline. So that makes it, extremely optional, but also we're trying to make this something that is added to the OVS solution overall without breaking stuff. So to summarize, you can run this today on IPDK. That version on IPDK it has a software target. We have two software targets that we're looking at. The default is using a DPDK user space pipeline, but there's also development of an eBPF pipeline. And we have this running on a couple different hardware targets, including switches and IPUs. And we really think that this can solve a really large space of use cases that start to get extremely complex without having to have brand new control planes or brand new concepts being introduced. We can sort of combine the pieces that you need. I need OVS, or I need Sonic instead, or I want IPsec, or I want some sort of different type of crypto. We can get to each one of these different types of usages and then combine them all together with P4. And then when we do that combination, OVS becomes just yet another control plane inside of the system. Thank you very much, and we'll open it up for questions. We'll open it up for questions. Hello, I don't know if this is working, but you can hear me.
follow up later.
Go ahead again.
All right, then can you hear us?
Yes, I can hear you. I hope you can hear me.
Okay. All right, yes, we can hear you. Do we have any questions in the room? No? Do we have questions in the chat? No? Okay. Then we have a couple minutes for questions, reserved for questions, but no questions at the moment. So I wondered if you have any, final thoughts that you want to share with your presentation.
Yeah, I would just like to say that the OVS conference is really special, at least for me. It's been a great place to go and interact with people, and I'm really disappointed to not be able to be there in person. But I've really enjoyed the presentations, and I just want to say thank you to the organizers for setting this up and being able to accommodate the people who couldn't be there in person.
Right, thanks. We definitely miss you here. Hopefully we can see each other in the next OVS conference. All right, let's thank again our speaker.